All right, welcome to the explainer. You know, we use computers every single day, but have you ever stopped to think about what's actually going on under the hood? It turns out, whether you're talking about a massive supercomputer or just the phone in your pocket, they all do the exact same four things. Today, we're going to break down those four basic jobs that really make our entire digital world go round. Okay, so let's get right into it. We've all seen a setup like this, right? You got your monitor, your tower, keyboard, mouse, the usual suspects. This is the hardware, the physical stuff you can actually touch. But the big question, the one we're going to answer today, is how do all these parts work together? How do they take our clicks and our typing and turn them into, well, anything useful? And here's the really cool part. It honestly doesn't matter what kind of computer we're talking about. It could be a giant gaming rig or a super thin tablet with a touchscreen. The basic idea behind how they work, it's exactly the same. The whole world of computing, everything, really just boils down to four simple jobs. So here's how we're going to tackle this. We're going to look at a really simple framework. First up is input. That's basically us talking to the computer. Then we'll get into processing. That's the computer's brain. After that, we've got storage, which is its memory. And we'll wrap it all up with output, how the computer talks back to us.
All right, let's jump into our first job, input. I mean, it makes sense, right? Before a computer can do anything for us, it has to get some information from the outside world, which is usually us. So simply put, input is just any way we give the computer data or tell it what to do.
And the most classic example of an input device, the one we all use, is the keyboard. It doesn't matter if it's a clicky one on your desk or the one that pops up on your phone screen. Every single time you type a letter, you're performing an active input. You're literally sending a little command to the computer. You know when you're typing and you see that little blinking line, that little vertical bar? Well, that has a name. It's called the insertion point, and its only job is to show you exactly where the next thing you type is going to go. It's basically the computer saying, okay, I'm listening, put your next letter right here. But of course, it's not just about keyboards anymore. We've come up with tons of ways to talk to our computers. You've got the mouse, the trackball, the touchpad, all for pointing and clicking. A scanner takes a physical piece of paper and turns it into digital input. Heck, even when you swipe a credit card, that magnetic reader is inputting your account info. They're all just different tools for the exact same job, getting information into the machine. Okay, so the computer has our input. We've pressed a key, we've clicked the mouse. Now what? It can't just sit there with that information. It has to actually do something with it. And that brings us to our second job, processing. This is the thinking part. This is the digital brain at work. Now, the grand central station for all of this processing is something called the motherboard. The best way to think about it is like the computer's central nervous system. It's this big main circuit board, and basically everything else, the processor, the memory, you name it, plugs right into it. It's what lets all the different parts talk to each other and work as a team. But here's a key detail. Not all motherboards are the same. What really determines what a computer can do is a little thing on the motherboard called the chipset. Think of the chipset as the air traffic controller for the whole system. It's in charge of everything: how fast data moves around, what kind of processor you can use, how much memory you can install. It's really the motherboard's DNA, and it sets the absolute limit for how powerful that computer can be. All right, quick recap. We've given the computer some input, and it's processed it. But it needs a place to put that information, right? Both for the stuff it's working on right now and for things we want to keep for later. And this brings us to job number 3, storage. And, just like our own brains, computers have both a short-term and a long-term memory. So when we talk about working memory, there are actually two kinds. The main one is system memory, which you've probably heard of as RAM. This stuff is blazing fast, but it's temporary. It's like your own short-term memory for whatever you're doing at this very moment. But what happens when that gets full? Well, the computer does something really clever. It uses a piece of the much slower hard drive as an overflow area called virtual memory. It's not ideal because it's slower, but it's way better than just crashing. It's kind of like the computer is writing a quick sticky note to itself to remember something so it can clear up some brain space. Now, for long-term storage, for saving our files forever, or at least for a while, we use things like hard drives or these optical discs. And it is just wild to see how much these things can hold now. I mean, think about it. A CD could hold around 900 megabytes. Then the DVD came along and could hold up to 17 gigabytes. And a Blu-ray disc, that can pack in up to 128 gigabytes. The amount of data we can cram into the same physical space has just exploded. And that brings us to the final piece of the puzzle. The computer took our input,
It crunched the numbers, it knows where the info is stored. But so what? We need to see the result. And that is the fourth and final job, output. This is all about how the computer talks back to us and shows us what it's done. The most obvious output device, by far, is the screen that you're probably looking at this very second. And how does it work? Well, it's basically made up of millions and millions of teeny tiny little dots called pixels. Each pixel can light up with a different color. And because there are so many of them and they're so small, our eyes just blend them together to create a single clear image. It's how you see everything from a simple letter A to a 4K movie. Okay, let's put it all together. Let's walk through the whole cycle with a super simple example. Say you're typing something. Step 1, you press the H key on your keyboard. That's your input. Step 2, that signal zips over to the motherboard. The CPU figures out what to do with it. That's processing. Step 3, the processor tells your monitor to show the letter H. Bam, that's your output. And then finally, when you're all done and you click save, that document gets written onto the hard drive for later. And that is storage. Input, processing, output, storage. That's the loop, happening billions of times a second. And there you have it. That's it. Every single thing a computer does, no matter how complicated it seems, is just some combination of these 4 jobs. And once you get this simple framework, it doesn't just help you understand your computer now, it actually gives you a great way to think about where technology is headed next. So here's a question for you to chew on. Now that you know the 4 jobs, which one do you think is changing the fastest? That's definitely something worth thinking about.